Okay, continuing with section 2.5. I was just finishing up number 6. And again, it was like number 5 that had a leftmost piece and a rightmost piece. These were the new points that went with the piece furthest to the left. And then we said we would plot this one, which came from performing these actions, using a solid point, and we would plot this point using an open-ended circle. Likewise, we had gotten these points as well. And I was telling you that you would plot this point. We did the same actions on these 2 points as we did on these 2 points because, of course, we're following this plan whenever we're translating. And we were going to graph this. This has to do with the rightmost segment with a solid point and this one with an open point. And I was going to leave the graphing to you. I went through all the grunt work, the algebra, and then you just plot these 2 points and connect them. Don't forget to make one end, this end, specifically solid and this one open. Likewise over here, make this point solid, this one open, connect them, and you'll see the things that are going on that I've already described for you here in this comment box. You should be able to describe the shifts and the translations that are going on verbally, as well as do the algebraic calculations that result in the new picture. So it'd be fine to do certain things in your calculator, but you can't do everything in your calculator. You can't take a problem where they've presented you with a figure and put that in your calculator. You need a function. So you need to know how to do these things by hand. Okay, here now you come to a different sort of a problem where you don't have a picture to begin with, whereas numbers 1 through 6, you did have a picture. So here, you're doing like a more advanced type of translation, but still the main gist of it is what you did in numbers 1 through 6. This is the kind of problem that you will find on your next test with respect to this section. You'll be asked to graph the original function, is what it'll say in the test, as well as the transformed graph. So this is supposed to represent your original graph. This represents your new transformed graph. Notice that they both have the same shape, which I will review your thoughts on that. If this is an X with a square on it, it's a parabolic shape. If this, you see that this one also has an X with a square on it. The only thing that it has different, this particular shape, that's also going to be a parabolic shape just like this one, is that it has a -2. That means it's going to look just like this graph, only with a vertical shift of -2. That's not one of the shifters that you switch. You'll see, notice the difference between where this number is versus where this number is in number 8. You see how that number is not inside the parenthesis, and I kept harping on that in numbers 1 through 6. That number is not inside the parenthesis with an X. Therefore, it affects your Y values. It is an action that gets performed upon the Y values, vertical shifting. Whereas this number that you see right here, this is a horizontal shift. You do this on your X's. So this one's a really good problem because you have things happening to the X's and things that are happening on the Y's. Like I said, I kept harping on when the number's with the X's, it is something you do to the X. That's a horizontal shift. You got to switch the sign first. And then when the number's not inside the parenthesis with the X, they are things that you do to the Y value. Okay, the only thing that is different starting with number 7 is that you're no longer babied into all the points. You have to come up with that original set of points. So super simple, just moving, super, not simple, super similar. That's the word I meant to use. Just you have to originate the first few points by just remembering that whenever you do a graph and you're coming up with your own points, it is your choice. And students lose that skill because they become much too dependent on using their calculators and therefore lose the entire essence of what it means to graph something. You pick certain values for X, allowable values for X. That's called using the proper domain values. You can't use anything that's going to make the function undefined when you go and plug it in. So that's called using things that are actually using X values that are actually in the domain. So you pick whatever you want. I would advise you to pick very easy numbers like zeros and ones, and you want some negatives in there as well, especially when you're doing a parabola that has symmetric legs. You want that nice symmetry on the graph, not just one side of it. Okay, so let's get ourselves organized with respect to how we're going to show the work. We have this original function right here, and we're going to do a table for that. Okay, remember when you're doing a table that you have a column of X's and a column of Y's, and it is the X's that you pick whatever you want. It's called the independent variable. Okay, now you have to pick more points when you're doing a parabola. I would suggest 0 because it is super easy to plug in. I would suggest -1 as well as +1. -2 as well as +2. Give me enough points to show that you know how to plug these points in. Okay, so let's do it. Remember, we're using this function right here. And then I'm going to tell you how to get all the points for the new graph, the one that's called g of x, x squared minus 2. We're not going to actually plug into that. You only do that, you only plug into the parent graph. But then when you go to get the points for the new graph, the translated graph, you're using the skills that I taught you in numbers 1 through 6, where you try to read the commands. Are they asking you to do something to X, or are they asking you to do something to Y? That will save you an immense amount of work as opposed to just plugging values in. Now, this new function happens to be pretty simplistic. You're only doing one thing, subtracting 2. But wait until you get to problems where there's a multiplier in front of the X and something being subtracted and something out here as a vertical shifter. Then you're going to see the significance of how much work you are cutting down on the problem by knowing how to do what I taught you in problems 1 through 6. It's really superior as opposed to just plugging in. Okay, so parent graph, we always plug into it and we pick simple values. So looking at this function right here, if you plug in a 0, 0 squared is 0, and whatever you're getting for the answer, that is your Y value because this stands for Y. So putting in a 0 there and squaring it, you get 0. Putting in, remember something, when you square a number, you never get a negative. It always comes out positive. If you put a -1 right in there and square it, that means -1 times -1. So this would be +1. When you put a +1 in there, that means 1 times 1. Again, you get a +1. Put a -2 in there. You're squaring the negative as well as the 2. That's why it never comes out negative. But what does it mean when you put -2 in there and square it? Squaring means take a number and multiply it by itself. So it would be -2 times -2, 4. When you put a 2 in there, of course, you get the same thing. Again, it never comes out negative when you're squaring a number. Not if the number is real as opposed to imaginary. Okay, this is the original parent graph. And you will graph that one and also the translated graph right on the same axes. That's what it means to show the transformation. Okay, so 0, 0 would be right here. -1, 1 would be right here. This point right here at 1, +1, 1, +1. Those are called symmetric points. They look like two eyeballs on either side of the y-axis. Those are called symmetric points. Every point on the legs of a parabola have symmetric points. The only point that doesn't have a symmetric point is the vertex. That's called the vertex. Continue plotting. Next point here is -2, 4. So right there. And notice how this point at 4 is 2 units away from the y-axis. So its sister point or symmetrical point will also be 2 units away from the y-axis, but both at the same height. But you can see that here, 2, 4. over 2, up 4. So you have that graph right there. Now you're going to create the brand new graph. Okay, so let's try and relate this to what we just did in problems 1 through 6. So this is what we're doing now. We're doing this graph right here. Doing another XY table. I already have the function there, so I'm not going to write it on top like this one. Okay, so let's read what this actually says. So, you're kind of breaking away from all the aids that I'm giving you because we've already done it through 1 through 6. So you're trying to fly a little bit more on your own now. This number right here is not inside a parenthesis with the X, as you see in this problem. Notice the difference. Here you're being asked to act upon the X according to the way the function's written. That is not the case here. So when the number is not inside a parenthesis with X like this, that means do it to the Y. So all you're being asked here is to subtract 2 from the Y's. That's all you're being asked to do here. Subtract 2 from the Y's. And I'll write it out for you the way I did in other problems, just in case you look at this later. You're not being asked to do anything to the X, because if you were, you'd have an X and then a command right next to it. They'd be telling you to do it right in here. You don't even have a parenthesis there. You're being asked to do nothing to the X. That means leave it as is. So you'll leave the X alone. And I'm talking about these values off of the parent graph. That's what I'm talking about. You know how in numbers 1 through 6, they gave you a picture and you would pluck the points off the picture? Well, you have points again. It's just that you created them yourself by knowing how to plug into the parent function. So you still have a set of points. So when I say do nothing to the X, we're doing nothing to this X value. I'm talking about these X values right here. So in other words, I'm basically just saying copy them. But on the Y's, we're going to be doing this. We're doing this action on the Y's. What Y's? The Y's off of this table that you created. Okay, so let's see. If we're going to subtract 2, 0 take away 2, negative 2. 1 take away 2, negative 1. 1 take away 2 again, same answer. 4 take away 2, 2. Same number here, 2. Okay, now you're going to go plot your new graph. So you have this original graph right here. Those were all the values from this original table. And now we have everything from this graph. And I'm going to go plot those. 0, negative 2. Excuse my dog. He's snoring up a storm. And then negative 1, negative 1, negative 1, which is right there. Positive 1, negative 1. Negative 2, positive 2. And then positive 2, positive 2. Notice again, you have all these sister images. You have these 2 points directly across from each other on either side of the y-axis. Those are symmetric points. You have these 2 points that are on either side of the y-axis, all belonging to your new graph. And this is what you're going to be doing. Okay, I want to make this very clear that you will be doing several of these on the next test so that I'm not pulling any punches with you. But then again, you do have quite a few indications and red flags as to what you're going to see on the test, like what you're practicing in my math lab for the practice test, as well as that PDF copy of the practice test that I've included for you in your Blackboard shell. And you'll see the kind of problems. Besides, they're also in the outlines. Okay, number 8, we're going to probably have to do that on the very next video. I don't know how much I can say about it because this is going to cut off, but you have a horizontal shift here, but you will be using a positive 3. That's the one where you have to switch. This is a vertical shifter. So you're going to actually